Count special triplets. So the program statement is you are given an integer array names. A special triplet is defined as a triplet of indices I, j, k such that 0 is less than or equal to I, less than j, less than k, less than n, where n is the length of the array, and nums of I is equal to nums of j into 2, and nums of k is equal to nums of j into 2. So we need to return the total number of special triplets in the array. And since the answer can be very large, we need to return 10 raised to 9 plus 7. So for the first example, 636, if we see 3, this 6 and this 6, so 3 into 2 is equal to this 6. 3 into 2 is also equal to this 6. So we have one triplet at index 0, at index 1, at index 2. In this case, if you see this index, so 2 into 0 is 0, 2 into 0 is 0, and that is also 0. 1 into 2 is 2. So there is no numbers to the left or to the right, which is equal to 2. So here also only one triplet is possible. Now in this particular scenario, if we consider 8, 8 into 2, 16. 16 is not present and 8 is the starting of the number, this array. If we consider this 4, then 4 into 2, 8 is present on to the left. 4 into 8 is present to the right. So that's one triplet. Is there any other scenario? No, there is no other 8 present. Let's check for this 2. So on to the left, we have 2 into 2 equal to 4. And same way on to the right, we have 2 into 2 equal to 4. So there are total of 2 numbers. So let's see what is happening. 8, 4, 2, 4, 2, 8, 4. So in any index, suppose say I am at this particular index, we care about the numbers on to the left and on to the right of this particular index or this particular number 2, such that 2 into 2 is present onto the left. Also 2 into 2 is present onto the right. So if we see like so, this says like we need to track whether 2 into 2 is present onto the left, 2 into 2 is present onto the right, and how much. So that's the main scenario that we need to see. So in order to track, we need to fast look up whether a particular number is present onto the left or to the right, we can make use of hash map. So here we will be making use of two hash map. One hash map to check on the right and one hash map to check on the left. So first we will be filling the right side. So we see 8 and 8 is appearing one time. Sorry, 8 is appearing one time. Now 4 is appearing one time. Now 2 is appearing one time. Now 8 is appearing two times. Now 4 is appearing two times. Now that's one initialization, and this is done in big of N now. Now we again traverse to this array. We start with 8. If we start with this 8, we'll just decrease this count to 1. We'll put it to the left. Okay. Now if we are at index 8, what is the value that we are checking for? We are checking for the value whether 8 into 2 is present in this right or present in this left. But initially, let me just initially like there is no 8 1. So because on to the left of the 8 there are no elements. So initially we have only the elements onto the right. So 8. So we are checking for 8 into 2 16. This is the target value that we are checking. So is 16% in this right? No. Is 16% here? No. So we do not have any answer. So our answer or the count will be still 0. Now we need to put 8 comma 1. and we will be decreasing here. Now we go to 4. We decrease 4's count from here to 1. So which means currently we are at 4. So on to the right, there won't be, like in this particular case, currently we are at 4. How many numbers are on to the right? It's only 1. Initially, like total, there are two fours in this particular array. But if we are at 4 and looking to the right, there is only one 4. So we need to reduce this hash maps count. So from this index, there is only one 4. So what is the value we are checking for? 4 into 2 equal to 8. We need to check whether 8 is present onto the left, 8 is present onto the right. If we check in this array, 8 is present onto the left 1 times. Okay, so that's 1. 8 is also present onto the left 1 times, so that's 1. So a total of 1 into 1, which is equal to 1. This is greater than this 0. So our count is updated to 1. So we have seen one good triplet. Now we will put 4 comma 1. Once we finish the processing, we put 4 comma 1 into the left hash map, so that if we encounter any other index, so let's move on. So we encounter this 2, and to the left we have 1814, and to the right we have 1814. So onto the left, so if we are at index 2, the target that we are checking is 2 into 2 is equal to 4. So we need to check in the right hand side how many 4 is present. We also need to check in the left hand side how many 4 is present, and that can be easily done by making use of this hash map. So at first, like when we are considering 2, we need to decrease the count, because onto the right there is no 2. Now we need to see whether 4 is present. Yes, 4 is present, and it is 1 time. So 1 onto the left, onto the right, onto the left is also 1. So 1 into 1 equal to 1. So 1 plus 1, C equal to 2. So thus 2 is the answer. So the time complexity, big O of n for first pre-populating this, plus we are again traversing through the array in order to count the triplet, which is also a big O of n. So big O of 2n, and space complexity, we are making use of an extra space, 2 hash maps, and that can also, we can say it's by max big O of n. So we will be able to solve this problem linear time complexity. So let's try to code it up. So if nums is equal to null, or nums dot length is equal to 0, just an initial check, return 0. Now I need 2 hash maps, number to right map is equal to new hash map. Same way, we need one more hash map, that is number to left map is equal to new hash map. Now we need to return it modulo 10 raised to 9. So it's a constant value. So that is, I'm just storing it as mod to int of 199 plus 7. I'm also taking the length. Length is equal to nums dot length. Now I'm initially going through the array and counting how many times each numbers appears. So 4, sorry, there is okay, 4 in num from nums. We will track it onto the right. So number to right map dot put of num comma number to right map dot get of default of num comma 0 plus 1. Now we will be traversing again, and we are actually, like if we are at a particular index, we are actually fixing it as the middle index j, and trying to find the other two values, which is equal to nums of j into 2 and nums of j into 2 on to the left and to the right. So same way for it, num from nums. At first, we need to decrease it from the uh, number to right map. So number to right map dot put of num comma number to right map dot get of num comma 0, sorry, get of num minus 1. Okay, we need a variable to store the triplet, so triplet is equal to 0. So now we have reduced. Now we need to check the target. So what is the target? Int target value will be num into 2. So we are checking for this target value on the number right map and also in the number left map. So int right count equal to get our default of 0. So if it is present, we will consider that value. Otherwise, we will take it as 0, consider it as 0. So number to right map dot get our default of target value comma 0. Same way we will be doing for the left count equal to number to left map dot get our default of target value comma 0. Now we need to increment the count triplet. So count triplet equal to count triplet plus 1 long number into right count into left count mode, and we will return the int of count triplet at the end. Let's try to submit to see whether there is any kind of mistakes that we have done. Everything is wrong. Okay, I missed to add it to the left map. So after we done, we have one number put of m comma number 2 dot get default of num comma 0 plus 1. Okay, let's submit. So that's it. So basically at first, like we are basically fixing the current index j. We are treating each and every number from this array as the jth index or the middle index of the triplet and trying to find whether that fixed index or the jth index into 2 is present on to the left, is present on to the right, and how many. If and we are mainly considering about the count, and if we get the count, then it's just 1 into the right side count into left side count, and we will just add upon, which will give us the final count triplet.